This Giaccotti-funded project was a collaboration between the University of Washington and the Boeing Company. The overall goal of the project was to develop an automated evaluation method of tool surface condition in composites manufacturing using machine learning and sparse sensing. Throughout this project, a multifaceted inspection method was developed with an intent of being implemented into a robotic platform and used for evaluating the surface condition of production tools during composites manufacturing. The novel technology uses industrial quality equipment in conjunction with machine learning tools to form a four-step automatic and comprehensive evaluation of a tool surface. The first step of the evaluation process is digital mapping of the tool surface using global imaging. During this first step, a wide frame image of the tool surface is taken. Then, supervised learning-based image analysis is used to detect potentially troublesome areas on the tool surface containing either aged release coating or contamination. The areas identified during this first step act as target areas for the subsequent evaluation steps. The second step is to take sparse wettability measurements on targeted areas that were identified during image analysis. During this step, water droplets are dispensed on the tool surface where their contact angles are measured to provide estimations of surface free energy. This step can be used to detect the age of release coating or contamination on targeted zones. The third step of the process is to take sparse FTIR measurements on targeted zones. During this step, a handheld FTIR instrument is used to collect IR absorbance spectra for release coating age measurements, and can also be used for a more thorough identification of contaminations. The fourth step of the process is to transform in-production measurements into high-fidelity laboratory measurements using Gaussian process regression, or GPR. This final step is necessary to increase the overall precision of measurements and mitigate the possibility of false positive or false negative tool surface evaluation during manufacturing. With implementation into a robotic platform, this multifaceted inspection method is able to provide manufacturers with real-time information about whether or not a tool contains contamination and/or aged release coating, and if it needs cleaning or fresh application of release coating before further processing. This automated tool inspection method has the potential to offer the Boeing Company and the aerospace industry several benefits, some of which include increased tooling durability, reduced assembly and production costs, and increased production efficiency.